What is prime factorization? What are the different methods for prime factorization and why prime factorization is so important? Let's understand all the important concept about the prime factorization in this. Let's understand what is prime factorization. To understand this, let's understand the meaning of prime and factors. Let's first understand meaning of word factor. A factor is a number that divides into another number without leaving a remainder. For example, let's take number 12. So number 12, it can be written as product of two numbers, that is 2 and 6. So 2 and 6 are factors of 12. Also it can be represented as 3 into 4 and obviously 1 into 12. So number 1, number 2, number 3, 4, 6 and 12. These are all factors of number 12. Now let's understand the prime numbers. Prime numbers are the natural numbers which has only two factors, that is number 1 and the number itself. For example, let's take number 2. So number 2 can be represented as 1 into 2, product of two number, that is 1 into 2, and this is the only way you can represent number 2. It has only two factors, 1 and 2. That's the reason number 2 is a prime number. Number 3, it can be represented as 1 into 3, and that is only one possible way. That's the reason number 3 is a prime number. Number 4, I can represent it as 1 into 4. However, I can also represent it as 2 into 2. So you can see number 4 has factor as number 2. So it has additional factor than number 1 and number 4, which is number itself. Hence number 4 is not a prime number. Number 5, it can be represented as 1 into 5, that is only one possible way, hence it is prime. Number 6 is not prime because it can be represented as 1 into 6 and 3 into 2. So it has another representation, hence number 6 is not a prime number. Number 7 can be represented as 1 into 7, and that is the only possible way. Hence number 7 is a prime number, and this list continues so on. Now we understood what is the meaning of word prime, what is the meaning of word factor. Now it's easy for us to make out what is the meaning of prime factorization. Representing a number as a product of prime numbers is called as prime factorization. Let's take the same example what you can see on screen. Number 12 has all these factors. However, out of all these factors, number 2 and number 3, these are only two prime factors. Hence, representing number 12 as product of these prime factors, that is 2 and 3, will be the prime factorization of 12. 12 can be represented as 2 into 2 into 3, and that is the only way we can represent 12 as a product of primes. Now let's understand the different ways to perform the prime factorization. The first method for prime factorization is called as factor tree method. So in this method we are going to draw a tree structure to find out the factor. So let's take example. Let's take number 42. So 42 has two factors, that is 2 and 21. Now you can see number 2 is a prime number, hence it cannot be factorized further. The number 21 has two factors, that is 3 into 7. Now 3 and 7 both are the prime numbers, hence we cannot factorize this further. Which means the prime factorization of 42 is 2 into 3 into 7. Now let's understand the other method. So the another method for prime factorization is called as upside down division method. So in this method, we'll perform division of this number from top to bottom. So you can see number 42 has two factors, that is 2 into 21. We'll further factorize 21 as 3 into 7. Now we have got our prime factors, that is 2 into 3 into 7. You can use either of the method to find out the prime factor of the number. Upside down method can save more space and time when factorizing a larger number. Let's quickly find out the prime factors of 72 using factor 3 method. So 72 can be factorized as 2 into 36. Now 2 is a prime number. It cannot be factorized further. The 36 can be factorized as 2 into 18. This 18 can be further factorized as 2 into 9, and 9 is divisible by 3. It has two factors, that is 3 into 3. Now we have got all the prime numbers at the leaf node. Hence the prime factorization of 72 is 2 into 2 into 2 into 3 into 3. In an exponential form, we can also represent it as 2 to the power 3 into 3 to the power 2. Let's find out the factors of 70 using the upside down division method. So 72 has two factors, 2 into 36. So this is 2 into 18, 2 into 9, and 3 into 3 is 9. So we have got all the prime numbers here. So the factors will be the same. And in exponential form, we can represent it as 2 raised to power 3 into 3 raised to power 2. Now let's understand the importance of prime factorization. The fundamental theorem of arithmetic is based on prime factorization, which says every positive number can be represented as a unique product of primes, ignoring the order, which means by multiplying the prime number, you can form any whole number, and there is only one way you can represent the number as product of primes. For example, 72, you can represent it as 2 into 2 into 2 into 3 into 3. That is the only possible way you can represent 72 using prime numbers. You can ignore the order. However, you cannot have any other combination of the prime to represent 72, which makes this prime factorization very useful in cryptography, which is a study of secret codes. Factoring very large number is very hard, and it can take computer a very long time to do so. Prime factorization can also be used to find out the HCF and LCM of a number. Prime factors are also used to find out the roots, like to find out the square root or cube root of a number. So these are the different areas of application of prime factorization. We hope, friends, you liked our work. Be in touch with us for more videos like this.